The last rule of conditional probability is what we call law of total probability. We define events A1 through AN, and we note that they're disjoint, meaning that they cannot happen at the same time. And in particular, we also assume that the union of all of the events is the sample space. Okay? So if you imagine that we have a Venn diagram here, which denotes the sample space, the box here, and then we have A1, A2, A3, A4, A5, and let's say N is 6 for A6. So this is disjoint events A1 through A6, and the union of the 6 events is the sample space. Okay, so you are putting probability for each of the events here, and then they sum up to the sample space itself. Then the law of total probability is that if I want to know another event, B, the marginal probability of that, then it actually becomes a sum of a sequence of products of conditional and marginal. So this, we know, is A1 and B, right? And then every term in between as well. The last term is AN and B. Right? So essentially, you list all of the joint probability of B of any of the AIs that we considered earlier, and then you sum all of this up, which will give you the marginal probability of B. So to illustrate the graph that we just did, let's just say B is this box inside S. So in order to get the probability of marginal of B, which is the box, the blue box in here, this that we're looking at the intersection of B of each of the AIs, and then we are summing them up. So you can see that this part is the intersection of B and A1, right? This is for A2, it's the intersection for A3, A4, A5 is the middle thing, and then A6. So in the end, we sum up all of the joint probability, which will give us the marginal probability of B. And lastly, just a definition here. Such collection of sets A through AN is also called a partition of the sample space. And so when you have disjoint events and the union all of the events are the sample space, then we call it as a partition. And then this can be super helpful when we're trying to come up with the marginal probability of another event using the law of total probability.